If you just look at the problem, you could figure out what's the GCF between 2 and 3. There's not one, right? It's 1. Okay, so then you could say they both have an x. So then you would say, well, what power do they have in common? And some of you can look at it and be able to tell just like that. If you can, that's fine. So you could look and say, okay, well, this has 2 ends, this has 1 end. So what do they share? 1 end. This one has a 3, this one has a 1. What do they share? 1. Okay? And then when you factor out, there were 2 ends, you took 1 end away, so what's left? 1 end. There was 3, you took 1 away, now there's 2. Right? If you can look at it and see it like that, that's fine. And then do the same thing here. X to the n, and you took n away. X to the first, you took 1 away, so the x to the n plus 1 is gone. All right? And if you can look and see that, that's fine. If not, we can break it apart like we did in those examples yesterday. And that's what I'm going to show you. So, you have here in the x to the 2n plus 3, that can be broken apart as follows. That's 2 times x to the 2n, x to the third. Remember, when it's being added, we could break it apart as multiplying them together. Minus 3, x to the n, x to the first. Everybody sees what I did there? Now, some of you may want to go even a step further, because here we have an x to the 2n. 2n can be rewritten as n plus n. That's the same thing as 2n. And now that it's being added, we would write that as x to the n, x to the n. Bring everything else down. 3x to the n, x to the first. We would have this. Everybody good with that step? Okay. Now then, if you are looking for the greatest common factor, the same steps apply. We've got a 2 and a 3, so I have no numbered GCF other than 1, which I'm not going to write down. All right? They both have an x to the n, right? So I can factor an x to the n out. Okay? And then I look, this one has an x to the third power, this one an x to the first power. What's the greatest one that they have in common? It's x to the first, right? It's just like any other one we factored to this point. So I'm going to take that x to the first out. And then what's left? I've got 2x to the n, x squared, minus 3, and I took that x to the first out, right? And then with some simple rewriting, x to the n times x to the first is x to the n plus 1. X to the n, x to the second is x to the n plus 2. And that's the final answer. Because if you want to break it apart into each step like this, that's fine. If you can look from the very beginning and pick it out, that's fine too. Okay, whatever way you see. Just looking at this, first, do I have anything in common between the two? They both have pi as their coefficient, so I can factor that pi out. All right? Now, the other thing, I have powers that are being added. So, again, the same process that we had on the problem before. Some of you can look at it and see what the common factor is, or you may want to break it apart. Right, so for me, I can just look. I know I've got an a to the 2b in both of them, and I'm going to bring that out. But if you don't see that, let's break it apart just like we did before. So this is a to the 3b, a to the first, minus pi a to the 2b. And again, for some of you, this may be enough. You can see a to the 2b. If not, you know which one has a more simplified variable. A to the 2b is more simplified. And if I can make this say a to the 2b, then I can get it to factor out immediately. Okay? So a to the 3b, that's the same thing as a to the 2b plus b. You get that? That makes sense? Because again, there's several different ways you can work this problem as long as you're logically sound. I don't care which one you choose. Now, a to the 2b plus b, that is a to the 2b, a to the b, a to the first, minus pi a to the 2b. Now, what do they both share? They both have a pi. They both have an a to the 2b. And then what's left? I've got an a to the b, a to the first. Oh no, they ran together. Hold on. Give me just a second. I'm going to see if I can get that green one to shrink. Or if they've already ran. No, there we go. Good. Okay, so this is pi. So they both had a pi. They both had an a to the 2b. So pi a to the 2b. And then what's left in the first term? A to the b, a to the first. What's left in the second term? A 1, right? There's no factors left, so it has to be a 1 when you factor them out. And then just like before, a to the b, a to the first, multiplying powers with the same base, you add the exponents. So that simplifies to be a to the b plus 1. Everybody see it that way? Any questions about this? I'm fixing to erase it and show you a different. No, you don't want to see another way, do you? What you could do, again, say that you didn't think to write this as 2b plus b. What if you did a to the b plus b plus b? You could do that if that's the way you thought. And then it would be a to the b, a to the b, a to the b, a to the first. And you would have to do the same thing here. This 2b is b plus b. So it'd be a to the b, a to the b. It'd just be more steps again. Again, I can keep showing you more and more steps, but you probably want to get it done in as few steps as you can understand. So if everybody's good with this, then I won't go to the next step. First thing I would do in this problem is I'm going to rearrange the terms to put them in descending order. Okay, so I want the largest exponent listed first to the smallest. And then I'm also at the same time going to change this mixed number to an improper fraction. Okay, because we do not like mixed numbers. So rearranging this, I get 6/7 x to the 5th minus 10/7 x to the 4th plus 2/7 x to the 3rd. Everybody good with that? Now, they all have a 7 in the denominator, so I know I can factor out a 7th. Then we're going to look at the numerator. They're all even. So 2/7 would be my greatest common factor. Okay, so I'm going to factor that out. Now let's look at the variables. I have an x in all of them. And then what's the highest shared power? It would be to the 3rd. Right? That's why it's listed at the end. So it's easy to tell. So now let's see what's left. I had 6/7 and I took 2/7 of them away. So how many are left? 3. And again, if you can't do that in your head, calculator that. You can just do 6/7. Sorry. You can just do 6/7 divided by 2/7. And it gives you that 3. Okay? X, it was to the 5th, now it's to the 3rd. So that's an x squared that's left. Minus, right, and again, 10/7 divided by 2/7. That gives us 5. Then I go from x to the 4th to x to the 3rd. That means I have an x to the 1st left. And then 2/7. I divide by 2/7. That's 1 x to the third, and I took x to the third out. That means there are no more x's left. So I just have that 1 left. Okay, so we're looking for the GCF here. And again, we've got a radical 5 x to the fourth minus a radical 10 x to the third. So we're looking for what they have in common. Now, pretend like the 5 and 10 weren't underneath the radical. What would be the GCF of 5 and 10? 5. Okay, and it's underneath the radical, so it stays underneath the radical. So it's going to be a radical 5 is the GCF there. And then you look above it, x to the fourth and x to the third. What do they share in common? An x to the third. Now, one key that I want to point out, notice how this variable is outside of the radical. Does everybody see that? So make sure you clearly can see in your answer it's not included underneath the radical. All right, and then we're going to go ahead and factor that out. So I had radical 5. I took radical 5 out. So radical 5 divided by radical 5 is 1. X to the fourth divided by x to the third is x to the first. Okay, now same thing here. Radical 10, and I take a radical 5 out. So radical 10 divided by radical 5 is radical 2. And then x to the third, I take x to the third away. That means I don't have any more x's there. Did some people leave just a 2 here instead of radical 2? Did somebody miss it doing that? No? Everybody get this? All right, first thing I'm going to look for is a GCF. Is there something in common in all of them? There's not in this. Okay, so the next thing I see, there are 4 terms. I'm automatically going to try to group them. The first 2 terms together and the last 2 terms together. Now that the first 2 terms are grouped together, I'm looking for a GCF among those 2 terms. And A is that GCF. So I factor an A out. What's left is x squared plus y. In order for grouping to work correctly, my parentheses must match. So I know that I want this one to also have an x squared plus y in there. So I go into that knowing this. The GCF of the second 2 terms is a b, right? But if I just factor a positive b out, then I'm going to have 2 negatives left in parentheses, which is not going to match. So I'm going to factor a negative b out. And in doing so, that leaves me with positive x squared and a positive y. So now my parentheses match, which means the grouping was successful. And now then I just write down the terms that were in front of the shared parentheses, which is a and a negative b. And then I write down the matching set of parentheses, x squared plus y. Okay, so here we go with another 4-termed problem. First thing I'm looking for, is there a GCF? Okay, between 2, 3, 4, and 6, the GCF is 1. So that's not going to do me any good. Do they all have an M? No. Do they all have an S? No. So I can already tell there's no shared terms between all of them. So there is no GCF. So 4 terms, the next thing I'm going to try to do is group them. So I'm going to group the first 2 terms together and the last 2 terms together. When I group the first 2 together, I ask what is the GCF there. They both have an M. So I factor the m out. That leaves me with 2s plus 3t. Now again, I know I need my next set of parentheses to match this one. In here, they're both positive. So what am I going to have to do to ensure inside my parentheses over here is also both positive? I need to factor out a negative. I know that going in. Okay? So I'm going to factor out a negative, and then what's the GCF? 2n. They both share an n. Does everybody see that? So now what's left? That leaves me with 2s plus 3t.
Tyler, Lori.
So now that I factored out this negative 2n, I see that my parentheses match. So that means the grouping was successful. So now I just have to gather my terms. So the first parentheses consist of what's in front. So that's m and a negative 2n. Then the second one is what matches. So that's 2s plus 3t. And that one is factored.